Well, we've looked at surface area for prisms, cylinders, pyramids, and cones. Now we're going to look at volume for those things. And when we talk about volume, remember, well, think about when we talk about area. If we've got the area, let's suppose we've got a rectangle down here, and we want to talk about what is the area of this rectangle. Well, we count the number of square units. We've got 1, 2, 3, 4, 5, 6. So the area of that rectangle there is 6 square units. One quick way to do it was we multiplied by the width times the length. We've got 2 this way. How many columns of 2's are there? Well, there are 3. So 2 times 3, and we get 6. Well, when we talk about volume, we're no longer talking about square units. We're talking about cubic units. So we're counting the number of cubic units in there. Now, with the prism, what we're going to do is we're going to get the area of the base and then multiply by the height. So that's all we do. We take the area of the base times the height. So for this prism right here, we know we've got a height of 2. I need to get the area of the base, and the area of the base is a triangle, a right triangle down there, and we're going to take 1/2 the base times the height. Yeah, I'm talking about the height of the triangle. Okay, 1/2 base times height, and then times the height of this prism. So it's going to look like this. So it's going to be 1/2 of 24, which is 12. This is 12 cubic units. Well, 12 cubic centimeters in this case. That would be the volume here. Now, if you look at, it's the same principle over here for the cylinder. Now, this is a right cylinder. What we're going to do is we're going to take the area of the base, which is pi r squared, and then multiply by height. So for the prism, we take the area of the base times the height. For the cylinder, we're going to take the area of the base times the height as well. So it's BH for both of these. However, for the cylinder, the right circular cylinder here, the base is circular. So it's pi r squared h. So in this case, this is going to be pi times 8 squared times 6. And that will be our area for that cylinder. Now, there's something we need to just pause and think about here a minute. There's this thing called Cavallari's principle. And it just says this: if you do have 2 solids, and if 2 solids have the same height and the same cross-sectional area at every level, then they have the same volume. So for example, these 3 shapes here, notice they all have the cross-sectional area of B, and they all have the same height. So these 3 solids would have the same volume. Okay, just something interesting to pay attention to. Okay, so what we had here was we looked at prisms and cylinders. Now we want to look at pyramids and cones. When we talk about the volume of a pyramid, we're going to take base times the height, just like with a prism. However, it's 1/3 of it. So with a pyramid, it's 1/3 base times height. And with a cone, it's 1/3 base times height. Okay, so with the pyramid, it's 1/3 BH. With the cone, it's 1/3 BH. However, the B is pi r squared. So let's take a gander here. Let's see what we've got. For this cone here, we've got 1/3 the area of the base, which is pi times 12.4 squared times the height. Yeah, there we go. 1/3 the base, there's B, times the height. Now it's going to be the same thing for this oblique circular cone. It's 1/3 the area of the base, pi times 1.5 squared times the height. And there you have it.